little while ago I made a video dealing with the basics of an alarm system and briefly mentioned the idea that you could hook in a Raspberry Pi for the alarm alerting module to be able to allow it to run a Raspberry Pi to do different things to alert you. Now, what's the advantages with hooking up a Raspberry Pi or a Arduino or a PC or whatever you might hook up to an electronic circuit such as an alarm? There are so many things that you can do with a computer here. They've got hard drives you can use to log information. You can look up information that you might have as far as conditions. Maybe you have it listed that you're going to be out of the house during certain times, and therefore an internal motion sensor should trip the alarm. But as far as what it can do whenever it alerts you, yeah, sure, it can log things. It can display stuff on a screen. It can communicate with other electronics through the general purpose input and output pins. Those are the little pins on the board here that allow you to send a signal to an electronic circuit or receive an electronic signal. They're pretty simple, but it takes some programming as well to get those things to work. And just like any other computer, that's one of the biggest things that they have that's different than the other ones is those GPIOs. But just like the other computers as well, you've still got like USB and other hardware that you can mess with, and even the network, so you can send stuff out over the network here and send it worldwide to be able to email you in your office if you're at work when that happened. And that's something that the Raspberry Pi can do, is it can look it up on a database and it can go, oh, in this time window we know this is a scheduled work day. It can maybe check your work schedule, pull it down, download it, read it. It can do all kinds of different processes. Well, this is going to look at some of the considerations that you should make if you're considering adding the Raspberry Pi as a part of your alarm alerting module, or really a lot of this stuff here is going to apply to a little bit of everything, but this is really focused on the alarm alerting module. So there's several different ways you can do that. Let's take a look at those. One of the ways is to have it to where the Raspberry Pi is always on. You're going to have maximum power consumption with that because, of course, it's always running your Raspberry Pi. The response time would be minimal. The amount of time that it takes for your Raspberry Pi to get up and run whatever program you need it to run, it's going to be minimal because the boot's already happened. That 15 to 30 seconds of boot time, maybe a minute, just depends on how it's configured. You know, if you have a whole bunch of services and all that on there, then it's going to take more time. But if you don't have as many, servers and everything else like that running, it's a lighter thing. Maybe you don't even have a graphical user interface desktop. That'll save some time too. It can get right on in. And so response time is minimal. It's the amount of time it takes to respond to, oh, I detected an electronic change, let's do something, not waiting for it to start up. The ease of setup is actually the easiest between that. It's the easiest to do by quite a bit, really. And the cost of setup is also least expensive. We'll look at what you need to do each of these later on in the video. But another option would be to let's see, the always on option would also be very useful if you're expecting it to trip quite a bit. If you're really trying to like log an activity, maybe you're trying to, see, how many times something that regularly happens is going to happen. Like maybe you're tracking your refrigerator and seeing how many times does a compressor turn on. So you've got some type of way of detecting that. And that's a part of what your alarm is triggering on. In that case, yes, you want it to be up because you don't want it to be starting up and shutting down all the time. If you're getting a lot of trips, that's the best way to do that. Or if you just want the maximum security, willing to pay the extra on the electric bill, which isn't very much. But if you're in a situation where you don't have as easy of access to plug-in power for it, if you're having to run it on a battery, that might be another consideration to think about. But if it's always tripping, that's a good way to do that. Or if you just want the maximum security for the minimum response time, or you just don't want to spend as much money or time in setting it up, that's why you'd use the always on option. Now, if you're going to go ahead and set it up, there's another way to set up where you can have it start up for the first time when the alarm is tripped. And then it will just stay on until you manually shut it down. The power usage is significantly reduced, especially if you don't have it trip right away. Hopefully it waits a while before it would trip. And in that case, you have a fair amount of time where it was down, and therefore not consuming power. But the response time is delayed for the first time that it trips, because it's got to do that boot time. And then it's got the any additional trips, it's minimal. It's just the time it takes to receive the pulse and respond to it. The system's already going to be up for the additional trips. Any additional times here your alarm is tripped. Ease of setup, it's going to be a bit harder than the always on. And then as far as the expense on there, it's going to be a little bit more expensive too. You're going to have a few more components to build, to add into it, to buy. There's also another way to do it where it starts every time it's tripped. It will start up and then it shuts down automatically after running whatever routine. So after it does the routine to alert you, to log whatever's happened, whatever you have it do it as its programmed routine, now it's going to automatically shut itself down and then try and start back up again on the next time it's tripped. So it's going to have that power on, do, power off part of its cycle. Power usage is very minimal on that, provided you're not tripping constantly, which even at that is probably less than using either one of the other two methods. It's delayed on every single trip though. Every single time your alarm trips, it's going to be delayed however much time is needed to boot. And it's by far the hardest to set it out. There's a lot more, and we'll get into exactly what you'd have to do with each one of these things. But that would be the hardest to set up. And most expensive as well. You're going to need many more components to do that. So let's take a look at what some of these things we're going to need to set these things up. For the always on, you need to set up a Raspberry Pi. That means you need to purchase all the stuff necessary to run a Raspberry Pi. Then you need to get a MicroSmart digital card, load the Raspberry Pi operating system onto there by writing an image onto that. And then you're going to, once you get it to where it's set up, then you need to write a program to monitor the GPIO. Now this can just be something that you're going to manually start because you're always going to have this thing on. So you can just start the Raspberry Pi, type this program in there, leave it on, keep it running. Now any wire that goes into GPIO, you do want to filter those things. Make sure you're not sending too much voltage or not enough voltage that's going to not be recognized, but definitely not so much you burn the thing up. That's something that you're going to use with anything you're going to use with a Raspberry Pi. You're going to need those top three, really. That's a step to do any Raspberry Pi project. And then you're going to type in that program that monitors the GPIO. It's going to run whatever program that you have when it's tripped, to where it's going to monitor that GPIO input and run that thing. So just on that event that wire becomes live, it now runs whatever routine that is. It now emails you in your office and says, hey, wire was tripped, a door was opened, look at your security cameras. So that's the whole process for that. Yes, it is. That's part of the reason why I've been doing a lot of teaching with the analog and digital, because any Raspberry Pi project is much more extensive than hooking up a few wires. I definitely recommend, if you don't need the Raspberry Pi, don't use the Raspberry Pi. Alright. And so that wire that you're going to hook, that filtered wire to the GPIO, that's going to be on your alarm trip wire. So the wire that went live whenever the alarm was tripped, one of those buses, you're going to have that wire going over to a filter for the voltage into that GPIO. And you might even consider a relay on that to make sure that you're not dragging the amperage of the rest of your project in through your GPIO. Trip on, stay on. This is where we're also going to deal with a little bit more with running the power supply as well to the Raspberry Pi and things we need to consider on this. But the other thing too is we're going to need to add an additional way of making it to where when that program, we're going to do everything as we did on the last one, plus this. So absolutely everything we did plus these other two steps are needed for have it start up on the first trip and then stay on. We're going to need to write an additional start program for the GPIO monitoring and the alert. So in other words, what this means is we need to make it to where it runs on startup. When we did it, the always on option, we can start that program manually. But now we're preparing to be away when we start this. So we need it to start itself, and we need it to be able to be run to where when that script runs, that's the first time it runs the alert routine. And any other time that it's having anything on that GPIO wire, just like the other version, it's also going to run the script for the alerting. The other thing we're going to need to do too is we're going to need to splice power from the power supply for a Raspberry Pi, those little micro USB power supplies that are strong enough to run a Raspberry Pi. Yeah, you need enough power to run that Raspberry Pi, and we need to wire that to a relay, which is something that we need to consider. Anything that comes off of our tripping module that's of any significant power usage at all, especially a Raspberry Pi, we want to run that off of a relay. Relays allow us to run more current for things, also different voltages for things. We might be resetting the amount of current we have, or we might be drawing more current. But we can have two separate circuits at that point that can have their own current and their own voltage. And that's why I like the relays so much. But we would want to wire in a relay, kind of like what we did in the alarm control relay, where we had it to where once the alarm started sounding, it stayed sounding even after I flipped the switch off. It's going to feed itself. Once it's already feeding the Raspberry Pi, we don't want it to just turn off that Raspberry Pi. That's something that's very bad for Raspberry Pis. We don't want to shut them down. We don't want to turn them off without shutting them down. They can corrupt their file system. Correcting that is usually as easy as rewriting your image to the MicroSmart Digital, but then that also means rewriting your software. So do you really want to do that? It's better off not to corrupt it, not to be removing it out all the time. Yeah, and it's really good to leave it like it should be, and make sure we don't ruin it, and make sure that it's able to run its routine. And so that's why we want to trip it on and keep it on by continuing to draw that power through that relay. And that's going to continue to power our Raspberry Pi until we get back. Then we can shut it down. Once we've shut it down, once we've seen it, it's gone down, then we can disconnect that power and reconnect it and make that interrupt happen to allow that Raspberry Pi to be actually powered off at that point. Not just shut down, but powered off and removed from power. So those are things that we would need for the trip on, stay on method. Now for the trip on and then shut down after we're done, we pretty well need to do a lot of this, except for that the startup program is not going to need to monitor the GPIO. We do catch a break on that. Now we're no longer monitoring the GPIO. We're simply running this as soon as it starts. The startup program sends the alerts. It's going to pulse a GPIO pin, and that's important because we're going to read that over there on a circuit board later on, and then calls for shutdown. This is one of those things we don't want to tell a Raspberry Pi to turn off without shutting down. So we don't just want to kill that power. We need to be able to have it, allow it to run through its shutdown routine. And then we still need to disconnect power, because what good is it if we try and apply power again if it's still got power? If you're familiar with a Raspberry Pi, once they shut down, they don't actually disconnect themselves from power. And until they're disconnected, and then reconnected, then they won't have they won't be able to start back up again. So once your power's off, you need to take away the power. Once you shut it down, you need to take away the power, so that way once you reapply it, it will start back up again. It will actually start the operating system and allow you to trip it again. Otherwise, you won't be able to trip it again. And maybe that's fine. If you don't need to trip it more than once, then that's fine too. But I would want to be able to have it to where it has a timer. This is where the circuit board gets that GPIO pulse, the one from that pulse we sent from the middle step here. It's going to start a timer that will cut the power to the Raspberry Pi. That way, once we reapply power, it will actually boot back up again. We won't just be reapplying power to a circuit that still has power, and Raspberry Pi knows no different. But here we come across a very interesting thing here. We are writing a program that upon startup, it's going to do these routines. It's going to alert, send the GPIO, but then call shutdown, which means how are we supposed to recover this Raspberry Pi for use anywhere else later on? Let's say we want to use this Raspberry Pi, we're done using it in the alarm circuit in another 2 more months, and we want to use it for something else. But it always shuts down immediately after it starts back up because we programmed it for that. So how do we solve that problem? We have to think ahead. Now, there is one way that you can do this, and this would be to rewrite the image to the micro SD card. It's how you can recover most issues with Raspberry Pi, as long as it's not a hardware issue. Any type of software, corruption, bad programming, viruses, anything else, you can rewrite the image to the Smart Digital card, and then you're good to go again. But then you lose whatever was on that previous Smart Digital card. So the other thing that we can do is we can think ahead on this. We can add code to scan for a condition, some type of a condition, and break from the alert and shutdown routine on such a condition. This means on the startup script. Instead of, before it sends any of the alert out or anything else like that, it's going to first check for something like maybe power applied to one of the GPIO pins, maybe a key being held down on the keyboard. And when you're running a Raspberry Pi, it can get a software update from somewhere else. Maybe you're going to call some other computer in your house that will be running, and it can get a message there, and if it gets a message there that says stop, then it won't continue with the shutdown. Therefore, it will just stay up. It will cancel out running this routine, and then it will allow you to reprogram it right there from the console and access anything else you need to. And this is useful too if you're keeping a log on that Raspberry Pi. You can't read it if all it does is starts up, writes the log, and shuts down. So this allows you to a feature, if you program this in advance, this allows you a feature which you can go ahead and cancel the alert, not get your text, not tell all your buddies in law enforcement, hey, go by, check on my house in a text, whatever you're doing with your alarm, and being able to activate it and read your logs and use that Pi as a normal Raspberry Pi. Thank you for watching.